All right. So the question we have is we have four charges and we are given how they behave when they are paired together. So we have charge 1 and charge 2. They attract each other. So I'm going to mark it like this. And we have charge 2 and charge 3. They repel each other. Then we have charge 3 and 4 attracting each other, right? So these are the three information that are given to us. The question is, which of the following statements are true? So what would happen if we compare or if we use charge 1 and 4? So if charge 1 and 2 are attracting each other, they are opposite. So either this could have been positive or negative, or this could have been positive, negative, and this positive. It is the same with this. So it could have been either positive, negative, or negative, positive. But for here, both of them should have been either positive or both of them should have been negative, right? So if I pair charge 1 and charge 4, what is happening? So we have charge 1 and charge 4. So charge 1 could have been positive while charge 4 is negative. Then they are going to attract. If charge 1 was negative, then charge 4 would have been positive. So it is also going to attract because they are opposite, right? Let's go over the other answers as well. Charge 2 attracts charge 3. That will never happen because it is repulsion. It is given in the question itself. So this is not going to happen. Charge 1 repels charge 3. Let's go over all the answers. Charge 2 repels charge 4. All right, so let's think about this D. Because the first one, the problem is we do not know whether the charge 1 was positive and charge 4 is positive or negative when charge 1 was positive, because we don't have any correlation between 1 and 4, right? But for the D, the charge 2 and charge 4, we can take these two scenarios and we can kind of compare. So when 2 was positive, 3 would have been positive as well. If 3 was positive, 4 should have been negative, right? If 2 was negative, then 3 should have been negative and 4 should have been positive. So when I pair second and fourth charges, what is going to happen? So if 2 was positive, 4 would have been negative, so attraction. So charge 2 and charge 4, they are not going to attract. So that is wrong as well. Then charge 1 repels charge 3. That also we can get a correlation because we have 1 and 2 and 2 and 3. So charge 2 and charge 3, right? So when charge 1 was positive, charge 2 is negative. When charge 2 is negative, charge 3 should have been negative. When charge 1 was negative, charge 2 is positive, and 3 should have been positive as well. And we are pairing 1 and 3, right? So when we are pairing 1 and 3, charge 1, if positive, charge 3 is negative. If charge 1 was negative, charge 3 is positive as well. So what is going to happen? They are going to attract. So that answer is also wrong. So we know this is wrong, this is wrong, this is wrong. So it is either 1 or 4. So it is a practice exam, you know where you got it from. So the answers could be wrong because if we are, or maybe we can do it. Oh, we can do it. We can do it. I think we can do it. Let's try. So if charge 1 was positive, charge 2 is negative. If charge 2 was negative, charge 3 is negative. If charge 3 was negative, 4 should have been positive. If charge 1 was negative, 2 is positive. 3 is also positive. 4 should have been negative. And we are comparing 1 and charge 4, right? My bad. I thought initially we don't have a correlation, but we have a correlation because 1 is related to 2 is related to 3, and 3 is related to 4. So we can make something. So if I pair 1 with 4, positive and positive, they are going to repel. It is the same thing with the second thing. So when you pair 1 and 4, they are going to repel. So the answer would be the fourth one. I mean the fifth one. All right. Hope that makes sense, right? Okay. Then we have a resistance, electric RC circuit, not an RC circuit, a resistor circuit. All of them have the same resistance, so let's mark them. So this is R, 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 and R. Oh, maybe that would be an issue if I mark everything as R, because they have given it as 10R/3. So let's not mark it as R, but let's keep it in mind that all of those resistors are the same. So how does the current through resistor A compares with the current through resistor B? So we know that when resistors are in series connection, the current through each and every resistor in the series connection is going to be the same. And when they are parallel, the current will divide based on the resistance ratio or inverse resistance ratios to be exact, right? So what is going to happen as a current starts here? So that will flow down this wire, and that will flow down A, and that will come to this junction. So since all of these resistors are the same, they will divide equally. So I will have equal amount of current that is passed through these resistors, and they will join back, and they will follow here, follow here, follow here, and here. So if I say this is I as well, I until this junction. So it is 3 R's, or R, I mean 3 R amount of resistance in parallel. So the current should divide equally. So I would have I/3 here, I/3 here, and I/3, and they will join there, and it will become I, and I. So we can now compare the amount of current that goes through B and A. What is it? 1/3 or 3 times that of the current in B, right? All right, so now they are giving you the total resistance as 10R/3, and the amount of current that passes through resistor A is what? So we know that if the equivalent resistance is 10R/3, that means we are substituting all the resistors with a single resistor of magnitude 10R/3 and with the same electromotive force EMF. So that is 10R/3. If this is the case, then we only have one resistor in the circuit. So we can say delta V equals to IR. So I can find the current in this circuit, which has delta V by R. Delta V itself is V, and it is 10R/3. So it is going to be 3V by 10R, right? So the current in this circuit is 3V, my bad, 3V by 10R, right? So if that is the current in this circuit, here also the I should be 3V by 10R. So everywhere there is an I, the current through those resistors will be 3V by 10R. So the answer is 3V by 10R, and V by R, what is the multiplication product? So 3 by 10. Moving on. Any questions? Moving on. Oh, what is the current in the B? Okay. So since we have marked down the currents that are passing through each and every resistor before doing this question, we know that the current that is going through B is I/3. So we know what I is, right? So what is I/3? So I is 10V or 3V by 10R, 3V by 10R. So I/3 is dividing this entire thing by 3 or 1/3. So that is V by 10R. So the current that goes through not only B, C, and D is V by 10R. Okay. Right. If the power dissipated by the resistor E is P, where is E? The power dissipated here is P. How much power is dissipated by resistor F? All right. So what is the equation for the power? So power is either given by IV or V squared over R or I squared, right? Because we know V equals to IR, and when you substitute V equals to IR, you will get 3 equations for the same power. All right. So we know that the current that passes through the resistor E is same as the current that passes through F. And we know the E and F are of same magnitude of resistance. So what is the power through those resistance? They should be the same, right? Because it is I squared R. The second one is also I squared R. So the power is literally the same for both of them. So the answer would be P. All right. So this is quite an easy question. Not much to think. Oh, right? 31st, an object of mass 5 kilogram is acted by exactly 4 forces, each of magnitude 10 Newton. Which of the following could not be a resulting acceleration of the object? So we have an object when we are acting it by a force. I don't know if I told you this, but let's say we have 2 forces. So the maximum of resultant force or resultant acceleration I could get from these 2 forces is the summation of whatever the forces. So it is going to be F1 plus F2. The minimum would be F1 minus F2, right? As if they are different. Let's say I'm having F2 and F1. Minimum would be F1 minus F2. So keep that in mind. So the maximum force is always the summation of the forces, and the minimum is always F1 minus F2. We are looking at the magnitude, so I'm just using an absolute value for you understand. So if you know the maximum force, it is simple as dividing it by mass to get the maximum acceleration as well, right? So understand that, right? Okay, so in this case, we have 4 forces and each of the force is 10 Newton. So what is the maximum force? Can anyone guess? It is the summation of all the 4 forces. Yes, exactly. If I can apply all forces in the same direction, that is going to give me a result, a maximum result, isn't it? Which is 40. So in this maximum case, so let's calculate the acceleration maximum, which is m over a. Sorry, force over mass, right? Because F equals to ma. So if I'm looking for acceleration, it is F over m. So the maximum force I can have using this 10 Newton forces, sorry, is 40 Newton, and the mass of the object is 5 kilograms. So it is 40 divided by 5, 8 meters per second squared, right? So that is the maximum acceleration. And just for your understanding, what is the minimum acceleration? Minimum acceleration is 0, because if I could apply 2 forces in one direction and the other 2 in the opposite, that is going to result 0. So the minimum acceleration is 0, right? It is not necessary to come to the answer, but the minimum acceleration is 0 meters per second squared. So this is the range of values we can have. Can we get 10 then? We can't get 10, so 10 is the answer for that. Okay. Any questions up until this point?